example 1. Here I have taken an IP address 72.160.12.4. Now looking at the value of the first byte, it is 72. It falls under the range 1 to 126. That gives clarity to us that it is a class A IP address. Now for class A IP address, we know the default subnet mask is 255.0.0.0. What I have done here is I have expanded the dotted decimal values to their equivalent binary values, both for the IP address and the subnet mask. So just to recap, this is 128 bit, this is 64. 128 bit is off as of now, this is 64 bit which is on. 64 plus 8 gives me 72, so this is the bit number 8 which is on. And similarly for 160, 12 and 4, I have set the corresponding binary 8 binary values. And the corresponding subnet mask has also been expanded in the similar way. Okay, so now we are going to perform a bitwise AND operation. For you to remember or keep in mind while we are doing this, 0 and 0 gives 0, 0 and 1 gives 0, 1 and 0 gives 0, and 1 and 1 gives 1. Okay, so let's perform the bitwise AND operation on these, a byte at a time. 0 and 1 gives me 0, 1 and 1 gives me 1, 0 and 1 gives me 0, 0 and 1 gives me 0, 1 and 1 gives me 1, 0 and 1 gives me 0, 0 and 1 gives me 0, 0 and 0 and 1 gives me 0. That is the first byte. And now going to the second byte, 1 and 0 gives me 0, 0 and 0 gives me 0, 1 and 0, 0, 0 and 0, 0, 0 and 0, 0, 0 and 0, 0, 0 and 0, 0, and 0 and 0, 0. So if you are paying attention, this is pretty simple, right? Because we are doing this operation, and anytime there's a combination of 1 and 1, that is only where we'll get a result of 1. Apart from that, it is going to give us zeros. So looking at, since all the bits for the second and third byte of the subnet mask are zeros, the obvious result is going to be zeros. So I can comfortably write it down as this. Okay, this would come here, there, and this would be here, and this would become 8 zeros. And now, having derived the binary values, if we convert them into decimal, this will give me what? 72.0.0.0. So this is, if you notice, this is our network address. For this particular given IP address, we have derived the corresponding network address, in which the first byte indicates the network, and now since the other, all of them are 0, that indicates that this is the host part. Now that we have determined the network part and the host part, it is very easy for us to say what is the broadcast address. The broadcast address would be, leave the network part as it is and set all the host bits to ones. Here the host bits are, if you look at these, are 24. So all of these 8 bits set to 1 would give me a decimal 255. For here also it will give me 255. And for here also it will give me 255. Now that we have determined the broadcast address, the value of the last host IP address is easy to determine, and that would be 1 less than the broadcast address, 255.255.254. And likewise, it is very easy to find out the first host IP address, which would be, just set this bit to 1. So this is the 72.0.0.1 becomes the first host IP address. 72.255.254 becomes the last host IP address. 72.255.255.255 is the broadcast address for this network. So, in a sense, given an IP address, we know what is the default subnet mask. Using the bitwise operation, we find out the network address. Once the network address is determined, we know what is the host part, and then subsequently we can find out the whole different values for first IP, last IP, and the broadcast address. So that's the example for class A. Next, let us try an example for class B.